Good morning, this is Mrs. Bennett, and this is our lesson about simplifying with square roots. So let's start off with a little bit of vocabulary. A radical is an expression that involves a root, such as a square root or a cubed root. And you can see these here. This is the square root of x, and then we have a cube root of x. There are many other roots, 4th, 5th, 6th, but mainly we're going to deal with square roots and then a little bit of cube roots. So let's start with the definition of a square root. This is the inverse operation of the square of a number. So for instance, 4 times 4 is the same as 4 squared, which is 16. And the square root of 16 reverses this operation. So the square root of 16 is 4. So by rule, the square root of 16 could also be negative 4, because negative 4 squared would be negative 4 times negative 4, which is also 16. Okay. Now, in a later unit, we'll be using this. So I'm going to cross this guy out right here. Okay, the principal square root is the one that is not negative. Okay, so when you see the square root of 16, the principal root is 4. The secondary root would be negative 4. We're always going to use the positive 4 unless specifically stated. Okay, we also have the perfect square numbers. And these are numbers that are created by multiplying two integers. And these integers have to be the same. So we have a list down here of these integers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, so on and so on. Okay, so 25, 64, 121, and 196 I left open, because you can see the pattern here. 1 times 1, 2 times 2, 3 times 3, 4 times 4. 25 is 5 times 5. 64 is 8 times 8. 121 is 11 times 11. And 196 is 14 times 14. And this list does continue. There's a whole lot of perfect squares. But the first 15 are the ones that you should try to get into your memory. You probably already know the first 10 up through 100. I'd like you to also learn these other ones. Okay? Because it makes this part easier. If you know the perfect squares, we can find the following square roots from memory and not have to use a calculator or write anything out. Okay, so the square root of 25 is 5. Square root of 81 is 9. Square root of 121, 11. Square root of 49, 7. Square root of 225, 15. And the square root of 196 is 14. And remember, these are all the positive roots, so these are the principal roots. If I wanted the other root, the secondary root, like if I wanted the secondary root of square root of 25, I would put a negative sign in front of it to tell me that I wanted the negative 5 root. That's how you tell the difference. But these ones here are all principal roots. Okay, so get this into memory. Make yourself some flashcards if you need to. We're going to use those to simplify. So on the back side of your sheet, you will see that we're going to learn how to simplify. And we're going to start with the square root of 45. Now notice, 45 is not one of our perfect squares, which means this is an irrational number. And as you remember from Unit 1, irrational numbers in their decimal form, the decimals do not terminate and they do not repeat. So we have special symbols for them, like pi or square root. Now with square roots, we can simplify these. Okay, so what we're going to do is we're going to first find the greatest perfect square factor of 45, meaning what multiplies to be 45. Okay, so 45 multiplies, or it's two of its factors are 9 and 5. There's also 3 and 15 is equal to 45. And there's some other ones. But this one right here is our greatest perfect square factor. So if you look on this list over here, 9 is on our perfect square list, where 5, 3, and 15 are not. So 9 is our greatest perfect square. So what we're going to do is we're going to take our square root of 45 and we're going to factor it using the perfect square. So it's going to be written like this. Okay, so the square root of 45 becomes the square root of 9 times the square root of 5. And then we can actually split this. We can split this into the square root of 9 times the square root of 5. And you can only do this with multiplication and division. And then what we can do is, since we know that the square root of 9 is a perfect square, we can simplify that to become 3, which is a whole number. So this is 3 square root of 5. And if you type this in your calculator, you will see that the square root of 45, let me show you on the calculator here. The square root of 45 in decimal form is 6.7 with an irrational decimal. And then 3 times the square root of 5 is the same number. Because we're not actually changing the value of the number. What we are doing is simplifying this. We are taking out as many whole numbers as we can, or perfect square numbers, and leaving a minimal root. And that would be simplified form. Okay. If you don't use the greatest perfect square, you're going to have to simplify again. So for instance, the square root of 32, that's irrational. That factors into 4 times 8. The square root of 4 times the square root of 8 becomes, square root of 4 simplifies, becomes 2 square root of 8. Okay? But if we look down here, 2 square root of 8 actually simplifies again. So this 8 is 4 times 2. So we can break this up into square root of 4 times square root of 2. Square root of 4 simplifies again to be whole number 2. So then we have 2 times 2, which is 4. And then we have a square root of 2 left over. It's much simpler if you get the perfect square first. So let me show you. With perfect squares, the square root of 32 is 16 times 2, which can be broken into the square root of 16 times the square root of 2. The square root of 16 is our perfect square, so he becomes 4, and the square root of 2 here cannot be simplified anymore. So see how much faster it was to use the perfect squares than it was to just use regular factors? You want the greatest perfect square. Okay, so what you are doing is you are always looking at this list to see what can multiply to be the root that you're trying to get. So 44, the square root of 44 breaks into perfect square 4 and 11. Square root of 300. Well, 300 is divisible by 100, and then I would have 3 left over as my other factor, which doesn't have any more perfect squares in it. So that's the 100 is the greatest perfect square. 98. Well, 98 is divisible by 49. So this is 49 times 2, and 49 is on our list. And you can use your calculator to try to figure out which perfect square actually multiplies to be the root you're looking for, if you can't recognize it automatically. Okay? So this one breaks into square root of 4 times the square root of 11, which is the same as 2 root 11. Square root of 100 simplifies to be 10, and we have root 3 left over. Square root of 49 simplifies to be 7, and we have root 2 left over. Okay, I'd like you to try the last 3. Please finish the square root sign here. Try these 3 and then show me in class. Thank you.